Okay, so my name is Daniel Thompson, and one of the things I spent a good deal of time doing a little while back is write a Rust training course, which I'm not here to advertise anyway, well, maybe a little bit, but mostly it's the fact that while doing that, I spent a lot of time thinking about how we might learn Rust, and that's what I'm here to talk to you about today, different paths we could take to learn or learn more about Rust. And this is what I hope you might already know about Rust. I'm assuming that everybody in the room here has come with the awareness that Rust is a memory-safe language, and that is what's largely driving interest in it through the industry. It's its unique selling point. There are many other selling points, but that's its most unique one, the way it handles memory safety. It's performant. It performs in the same space as C and C++. Whether it's faster or slower than C depends on how many of the security mitigations you turn on in C, roughly speaking. But they're in the same ballpark. And then we hit the bit of today's topic, hard to learn. That's debatable, but there are elements of Rust that are quite complicated, and that is one of the things that intimidates people wanting to start learning it, which I'm hoping to dispel a little bit. And final thing that we learn about Rust, it is productive. There are ways to be very, very productive in Rust, partly because the tools are great, because it has compact syntaxes for certain important things. So that's what I hope you already know about Rust, and then we get into ways that you could try and learn more than, 7 words. So the big 3 tools with which you can learn Rust are exactly what you'll find on rustlang/learn. And the first of these is just called The Book. It is the Rust programming language, and it's a narrative introduction to Rust. It's not a reference to the language or how it works. It's a narrative introduction. It is very well structured, and it chooses not to introduce all of the language. There are features of Rust it actively chooses not to talk about in order to keep it concise and manageable. Even better, you can access it for free via the web, or if you prefer it in paperback or ebook format, you can purchase those. And what I would recommend about the book is A, read it from cover to cover, and B, don't try and be able to reproduce any of the syntax. My own experience of reading the book is I got to the end, I sat down, and I couldn't even remember how to spell the main function at the end of the process. And that's okay, because what you've learned from reading the book is a broad swathe of elements of Rust that when you are faced with a design problem, you'll be able to reach for the tool because you know it's there, as opposed to be ignorant that that language feature is in existence. And it's actually this Rust by example that is a much better reference for spellings. This is a well-structured collection of Rust code examples based around and organized by language and standard library features. So most of the stuff that you can see in the book, you can also come and find the same language features in Rust by example, and that's how you use a reference to look up the spellings when you get to that point. So that's my advice. There are other ways you can do it. And in fact, I told a very good friend of mine that he should read the book from cover to cover. He's a very smart fellow, and he made a face and said, oh, no, reading's not really my thing. And there are other paths you can take, and Rustlings is a very interesting alternative path through. Rustlings is basically a bite-sized collection of syntactic puzzles and a few writer function puzzles. If you think about trying to learn Spanish with Duolingo, Rustlings is trying to learn Rust in a similar manner, in small, bite-sized chunks. It won't introduce you to all of the language, but it does help you get used to the syntax and the compiler and these other things. And so those are the big 3 tools. They interact very well. You can use all of them, and the book and Rust by example in particular are really great complements for each other. The next thing we can do to learn Rust is allow the tools to help us as much as possible. And if there's one thing you take away from this talk is that if you are learning Rust, you must set up Rust Analyzer somewhere in your editor. And the reason for that is, some people think this is really obvious because anybody recent who comes to programming starts with that for C and all the other languages as well. For those of us a little bit older, perhaps, we did used to open an editor, close the editor, type make, remember the errors in our C program, open the editor again and fix them all. Which is not the most efficient way, but it becomes a bit burnt in. Rust Analyzer, the key thing it's giving us as learners is check as you type. The very nature of Rust having a slightly more dogmatic compiler that finds more problems for us, it is harder to write correct Rust or compilable Rust, than it is to write compilable C. And check as you type is the thing that stops you going too far in the wrong direction, having made a fundamental mistake in an early part of the program. So there are other things you get from Rust Analyzer. It gives you type information, which is really helpful if it's, as I said, a tooltip or an inlay hint. Obviously, it's got the autocompletes, function signatures, things like that. I'm not nearly as dramatic about this last bit. I would recommend you set up Rust format to give you format on save, for the simple reason that that will break you away from whatever your C coding style is and make you adopt a much more idiomatic Rust coding style. You could still learn Rust perfectly adequately with a non-idiomatic coding style, but you would find other Rust harder to read. So certainly there is more agreement on code formatting within the Rust ecosystem at the moment. There are other things you can use to learn Rust that are also tools. So we have Clippy. Clippy is named after the famous Microsoft paperclip, and it adds 700 additional linters. And some of those are extremely dogmatic, and you might choose to turn them off. There is a syntax to do that. But the key thing that Clippy brings is insight into idiomatic Rust. It makes your code move beyond being correct and functional to potentially more idiomatic, which this is an example of. So this syntax up here is taking a reference to a vector. And a vector, much like a C++ vector, is an automatically growable array. And because Rust makes you mark things as mutable, this is a constant reference to a vector. And it can be placed with a constant reference to an array slice, and the function can still be called with a vector, but it now becomes a more flexible function. So there's no downside that I'm aware of in making that transformation. Clippy will advise you to do that. It's a really good way to pick up pieces of idiom that you might have missed. And then we have a final tool that can help us learn Rust. This is called EVCXR. And it provides a read, evaluate, print loop for Rust. And how you feel about this, lots of different ways to learn. But one of the things that made Python easy to learn for me is that every time I had a curiosity about what you could do in Python, I could go and type it into a REPL, interactively work through it, and I would understand the language a bit better as a result. So what we can do with EVCXR is if we've installed Rust already, I'm not going to tell you how to do that in this talk, but you've then got cargo install EVCXR_REPL, and that will provide you a new command line program called EVCXR that you can run, and that will give you the chance to evaluate Rust expressions. So here we have a simple example where I've assigned an integer. I've then used Rust's ternary operator, which is basically an if statement, because statements and expressions are essentially the same thing in most of Rust. But it doesn't make sense, and the reason it doesn't make sense is the dangling else problem, because the as doesn't know which bit of the if to pick up. And I could then interactively experiment, spell it correctly, and get my absolute value function almost working. There is a numeric overflow in this particular example. So that's a really great tool that you can use to help you learn Rust. And then we move on to perhaps some habits that can help you to learn Rust. And the one I suggest is making Rust your scripting language. And this does sometimes hit elements of confusion. I don't mean scripting as in shell scripting. Shell is still a fantastically good language to hook together command line tools. Python, Rust, whatever it is, don't fill that gap. But the gap that I used to fill with Python, when I, for example, got a list of customers that I had to train in some crazy CSV format, and I needed to pull it out and put it into my mailer, I would tend to have a quick hacky script in Python that would pull out the bits I need and push them where I want them to be. These days, I would write that in Rust to allow myself to practice the syntax routinely. I don't get to write Rust full time, so it keeps me fresh when I need to write some Rust that's a bit more complicated. And this is an example of how I would recommend you do it. You'll find this in my slides, you don't have to memorize it, but the basic idea is we just create a directory to hold our collection of throwaway Rust scripts. I've called it my toy box. And we're relying on the fact that Cargo automatically discovers source code. So when you do Cargo in it, it will create you a hello world program called main.rs, and we can rename it to source bin hello, and Cargo will still automatically discover it and build it and allow you to use it. And the key value we get is that we can create a second and a third and a fourth program, put it in bin, run a cargo install command, and the compiled version will get dropped into our path ready for us to use. So if you're wondering about the grey stuff on the other side, those are other ways that you can use Rust as a scripting language using different techniques, which are all perfectly functional, perfectly effective, but they don't integrate with Rust Analyzer. And everything I told you about the importance of Rust Analyzer helping you write correct code means that if you use Rust as your scripting language using one of those techniques, you don't have support from your editor. So this technique gives Rust Analyzer fully built in if you've set up your editor correctly. If you want to know what that looks like in practice, I've not included a lot of Rust syntax in the presentation. There are costs. Rust does have ceremony that Python doesn't. Python is remarkably free of ceremony as a language. But there are still like direct links. You can link the namespace management and the namespace management. You can link the creation of the reader type. You've got the for loop. The reason that Python is a little bit complicated is I wanted to have the error checking in that would tell you if you've got a malformed line in the file, just because Rust was giving that for free. There is a simpler version of the Python that's about 6 lines in total, which is fine if the input's well formed, but that's what you'd have to do if you were going to try and find where you got a mistake in your CSV file. So the only major difference is this structure definition that maps CSV names to the names in our structure definition. And my experience is the longer, I didn't craft this to make Rust look good. This was just a real example for something that I did happen to do while I was writing this. The problem, the difference gets better. The more complicated the script, the fact that there's extra ceremony, the cost of that kind of goes down. So I still think Rust is a good option to use instead of a scripting language. But we can move on to other things, other techniques and tools that we can use. And I really recommend Advent of Code as a learning tool. I'd recommend it for learning any language. All the Advent of Code is a collection of small programming puzzles that are released once per day during December. So some people like it as a little workout to things. And the author, I haven't actually managed to capture their name, but their author has a really good habit of forcing the use of classic computer science solutions to a number of the problems they present to you. And I recommend it for any language, but the reason I recommend it so much for Rust is it will help build your insight into the sort of code that's really easy to write in Rust. Anything, as soon as you do string manipulation, if you're a C programmer, you're going to think, oh, wow, this is awesome. And it's why it's a good scripting language. Then as soon as they force you to solve the problem using a tree structure, tree-like data structure, and you immediately start working with pointers, and you can't figure out how to spell the syntaxes to get the lifetimes right so that we make sure that the tree is memory safe, or we have to give up and move into unsafe code and so on. That gives you the sense of things that are hard to borrow check. So in addition to helping you exercise the syntax and become a better Rust programmer, additionally you'll get more insight into what is hard in Rust and what's easy in Rust, because it doesn't make every program equally easy to solve. Next that comes through is embracing cargo and crates.io. And there's a tendency that's especially strong in C programmers, especially kernel programmers, is to build up all of their own infrastructure, to build their own libraries of tools and toys and things to play with, and not drag in unnecessary third-party code because it creates dependency hell. It's not that that's the wrong instinct in all situations, but as a new Rust programmer, I think you have to set it aside and start using the highest quality third-party components you can find. Primarily because the good quality libraries have good quality APIs, and you are allowing yourself to learn about what good Rust API design looks like. So if you don't use best-in-class crates to help you solve problems, you don't get exposure to code written by Rust programmers who are significantly more expert than you. The problem you'll get, I don't think you'll be able to see it on the board here, but there is 130,000 crates to choose from, which is an overwhelming amount of choice. There's no way you can tell the difference easily between a high-quality idiomatic crate built by an expert and something that was written by a beginner in C transposed into Rust syntax. Yeah, so the reason we have these other tools up here is to give you a spectrum of tools to help you filter out and find those high-quality crates. So all you can really do on crates.io is some kind of popularity contest. You can look to see how often they're downloaded, use that as a proxy for importance. You can see how often they're updated, which is a proxy for how well maintained it is, and so which is something that lib.rs automates for you. That gives you access to the same 130,000 crates with alternate sort ordering, so that when you type something into the search box, the ones at the top, to some extent, are more likely to be the high-quality idiomatic crates that can help you out. Blessed is a really valuable extension of that. Blessed is curated. Blessed is somebody's opinion that these crates are good crates. You don't know that they're always right. They are just a random person on the internet. But they probably know Rust more than I do and more than you do. So the statement that these are good high-quality crates is very much worth listening to. You can still go back to libs.rs and confirm their intuition and everything else, but having a curated list of high-quality crates is valuable to get started and make sure you kind of learn the good APIs, the good structures, the way other people solve these problems. You can also use this when you're presented with a computer science problem that's hard to solve in Rust. You might well be able to find a third-party library to help you solve it more elegantly. And at this point, if I've got my timing right, I am hitting the things I've had to omit from the course. So there were lots of other things I wanted to mention. But this is now I'm providing links for other things that you can go off and read, other content that you can look at. So there is some really great YouTube content on Rust. There is much more than I've put on this slide. I took the view I was only going to share things that I'd personally experienced and recommended. I'm not just going to go and read the YouTube index for you. But yes, the Rust talks by No Boilerplate, a chap called Tris, are fantastically good. They're very, very information dense. They run to about 10 minutes each. And they're a good mixture of philosophy, so discussion about important elements of Rust, idiomatic nature of Rust, why Rust is good for particular pieces, together with practical use of syntax and other pieces. It's just a really good collection of talks that are quite a mixture of thought-provoking and learning from. At the other extent, you have Crust of Rust by John Jengs, who is also the author of Rust for Rustaceans, which is an excellent advanced Rust book. If you move on from simply learning the syntax to trying to get more idiomatic, Rust for Rustaceans is a good book to use. Crust of Rust is long-form videos. We're talking up to an hour in places, where he will deep dive on a particular topic. And because of his pedigree and his capability, those long-form videos can be quite interesting as well. And then from the single videos, there could be many, many more single videos. But the one I bring up is type-driven API design in Rust. And this is a deep talk, to the extent that I've watched it about 4 times through the process of myself learning Rust. The first time I watched it, I could get a whole 10 minutes in before it started to go over my head. As I learned more about Rust, I could get further through the presentation before I started to get muddled about what he was talking about. So that one's got some depth. It's worth watching early to get a sense of where things are going. But you also get this sense of, well, I'll never be that good. So don't let it intimidate you and come back to watch it again at a later point. So we move on to, let me just check where I am, yeah. So moving on to the kind of online reading list. Read the book from cover to cover, again, potentially. Chapter 15 is the one where it talks about, references, I believe. Yeah, the book is recommended reading, goes without saying. And as I mentioned at the beginning, it is not complete. It doesn't describe the whole language. There are things and elements of Rust that you still need to find more about. So I've picked 4 particularly important books that I think are also worth considering. Asynchronous Programming in Rust introduces asynchronous programming in Rust. And the way Rust implements asynchronous programming is, I think, unique in the way it separates the creation of a future from the executor that will cause the future to actually run. So yeah, it's an interesting concept. And like a lot of Rust, you have to embrace the crates ecosystem to really make it sing. So you learn about the syntactic features that implements asynchronous Rust, and then you need to go and find an executor from in the crates ecosystem. So if you are a web programmer, or if you are a full bare metal firmware where you have no operating system on a microcontroller, those are particularly worth looking at asynchronous Rust. If you just want to round out your understanding a bit and try and find out when async is going to work for you and when it isn't, it's also worth looking at. In particular, if you start wanting to fetch things from the web in little command line utilities, asynchronous Rust will quite often come up because all the request tools default to asynchronous. So that one's there as a language feature. The Cargo book is for pragmatic reasons. It's not about learning the language. Cargo, unless you are working exclusively on the kernel, which does use a separate build system, pretty much everything else written in Rust is built using Cargo. And Cargo is a combination of packaging tool and build tool. And when you hit the thing that you need to, when you hit the thing where you would normally have reached into AutoTools or CMake to adapt your program to whatever it's running with nearby, the Cargo book will show you how you can write build scripts using Rust as a scripting language. It will show you how you control compile modes, change the optimization settings by default, and so on and so forth. So just the practical elements of how to package software for Rust is what the Cargo book discusses. If you get really into making Rust your scripting language, then command line applications in Rust is definitely worth your attention because, again, it's curating things for you. It will introduce you to the best-in-class command line parsers, and that's definitely worth doing because you don't want to carry your GetOps C baggage with you, and the idea that GetOps is the pinnacle of user interface design. So yeah, it brings you into the kind of Rust-like idiomatic ways of writing command line applications. And then finally we get to the Nomicon. So the Nomicon is the Bible of unsafe Rust. I haven't mentioned unsafe Rust at this point, but the nature of Rust is sometimes the borrow checker is too fussy and you cannot explain to it why your code is correct. Unsafe Rust does not change any of the rules about writing Rust. It just means the compiler can't guarantee your code has met it. So when you need to talk to unsafe Rust, the Nomicon is a comprehensive introduction. In my experience, I have only reached for the Nomicon when I want to interface to C. C is intrinsically unsafe, so you have to use the unsafe mechanisms to communicate with it. And that's the place where I always want to make sure I've got things right, pay attention. But other elements, when you need to use unsafe Rust, that is the book that you learn about. My recommendation is it's as and when you need it. It's ad hoc. You don't go out and read the Nomicon. You wait until you have a problem that you can't solve in safe Rust, and then you go and find out how the trapdoors work. It's not that useful to read about unsafe Rust really early, unless you're linking to a C library. And then the Rust standard library and docs.rs are auto-generated, kind of like Java doc and similar ecosystems, describing almost every Rust library there is. So the Rust standard library is a link to the Rust standard library. It's worth learning how it's structured, but all Rust code tends to end up on docs.rs, which takes that 130,000 crates, generates the document for each one, and makes it available as an online resource. So you can study the APIs of pretty much every part of the Rust ecosystem. So they're all worth looking at, but just to give you starting points, I've picked two, which is Iterator and String. And possibly while you're looking at iterators, you could also look at itertools, which is a third-party crate to extend the iterator a little bit. The iterator is worth learning because iteration is highly idiomatic in Rust. It hits the same kind of Pythonic element of for loops that iterate over elements and gives you some sophisticated ways to program in a functional style and other things. So the iterator is a key part of idiomatic Rust, and it is going to be fairly new to anybody from a C background. They exist in C++, they exist in lots of other languages. They're always slightly different between the languages, and it controls a lot of the look and feel of a language. So iterator is worth reading, and String is also worth reading because strings are fundamental. Being able to effectively work with strings is just a valuable thing to do. And finally, String also lets you compare string and str. Str is a slice of strings. It's a string that doesn't have automatic allocation and things like that with it. And the reason to compare those is it just helps you understand how to navigate the Rust docs better as you study. This was just an illustration of why learning about iterators and itertools is a good idea. This is not something that you could describe in C very effectively. You can do it in C++ these days, but it's just going through standard input line by line, running filters on them to handle errors, and then sorting things. So this one it's not a useful program, it just does a Christmas tree sort of the things, giving you the longest lines at the top. But that's why we look at itertools, it's why we look at iterators, so that we can use that approach when it is the right solution for us. So to kind of wrap up and summarize, how to teach yourself Rust. I said that this talk was about many ways to learn Rust, and I will acknowledge there are many different paths you can take to learn Rust. But this is the one that kind of summarizes this is one that summarizes my approach. Read the book from cover to cover. I think that should be kind of well understood as something I care about now. I like to say bring an empty cup when you are learning Rust. Try to leave some of your C ideas at the door. Try to leave your Python ideas at the door. And like I say, embracing cargo and in other elements, don't get hung up on dynamic linking and the things that are different in the Rust ecosystem to your experience. Try to learn why Rust is structured as it is. You may still have to break out the box. You may still have to dynamic link. You may still have to do things that are slightly ugly in Rust. But take that empty cup while you're learning it. It helps you learn better. Using the tools, I don't think I have to beat that again. Rust Analyzer, treat it as mandatory. The reason we talked about Advent of Code is all about making the right first steps. If you look in the longer PDF that's attached to the program, I had some ideas about better first steps. There's a tendency to say, I'm going to rewrite such and such so that I can learn Rust. What you then end up with is a rewrite of something that needs rewriting because you were still learning Rust while you're writing it, which is fine if that's what you intend to do, if it's deliberately writing throwaway Rust code or experimental Rust code. But rewriting something in production until you actually know what you're doing is going to need a version 2. So that's what we mean by right first steps. Try and think about how much you know and what you need to cover next. Being the right amount of curious harks back to making Rust your scripting language. That is accepting that your productivity is going down a bit. Right? If you can't remember how to spell main and you say, oh, I'm going to write this useful tool now, I would have written it much, much quicker in Python than I would have written it in Rust in the early days. The right amount of curious, I will say, is if something doesn't feel right, that means you indulge your curiosity, you go and find out why it doesn't feel right and see if there's something you can learn from that process. The wrong amount of curious is observing some of the macros doing useful things for you and thinking, right, I've got to put everything down and learn how macros work. Macros are quite a complicated part of Rust. It's tremendously powerful. It's a lot of where the productivity comes from. It doesn't mean that right there and then while you're trying to write a script in Rust, you have to go and study how macros work. You can just soak up the high-quality API and learn what APIs should look and feel like. And then when you need to create an API, that's when you can start studying the macros. So you're just exposing yourself. But that's when we make right amount of curious. When something feels wrong, you have to trust yourself and go and learn more. When something looks clever, you don't have to figure out how the cleverness works quite yet if you can write correct and working code from it. And then finally, I've used the word idiomatic a tremendous amount in this presentation. That's because of that tendency of particularly C programmers and to some extent other programmers from other cultures coming in and writing writing C in Rust syntax rather than writing Rust. So in addition to working out how to make Rust do something useful, your time is well spent learning how other Rust programmers would solve the same problems. So with that, I am on time. Awesome. So with that, I have my selection of silly pictures. If you would like to debate, argue, discuss, ask about Rust, come to support@linaro.org, where you will actually be sent to me because I run the support outfit at Linaro. And if you did want to talk to me about training, then there's also an email there that you can use if you would like to. I'm very happy to take questions now. We're coming up to a break, so we aren't going to get thrown out of a room immediately. Yeah, is there anything anybody would like to throw in? Stunned silence. How many people have already read the book? Good, you've got some homework. Brian.
Well, how long would you say it would take somebody with zero experience of Rust to meaningfully write insertion sort or bubble sort, for example? Something simple.
That does, to some extent, come to the right first steps. One of the unique things about Rust, well, I don't say unique, when you learn C, one of the very first things you learn in C is how to write a linked list. And that gives you this perverse idea of two things. One is that a linked list is a good data structure. And the other is that a linked list is simple. A linked list is not simple, it's tremendously complicated. It's just a concept that as people who have learned to program, we think is easy. And the biggest challenge in the whole empty cup thing is in part because things that you think should be easy, because that's what C makes, are actually some of the things that are most difficult. There's another document I perhaps should link to, it's called something about so you think you want to write a linked list in Rust. And it does tell you how to write a linked list in Rust. It's not that you can't do it. It starts off by explaining why it's the wrong data structure 9 times out of 10, because there was some interesting studies with vectors, and they're almost always faster, because the cost of moving the vector compared to the cost of maintaining the pointers, even in aggregate, tends to be vast. There are places in the Linux kernel is a place where a linked list actually does make sense because the memory allocation constraints. But that idea of what is simple, I really like suggesting people manipulate text, working through text files. And the reason for that is because it's actually in the long form of these slides. It's because that naturally encourages copying, it naturally encourages pure functions, and it naturally encourages dynamic string manipulation, all of which the Rust standard library is really good at. And that gets you comfortable with the syntax before you do something difficult. So that's my thoughts on it. That doesn't mean you couldn't charge in and write things like bubble sort. You clearly can, because you can have an array, and yeah, writing a bubble sort over an array, and then probably packing it in a trait so that it gets, there's a thing called trait extensions, which it's a technical thing that you would discover if you read the book from cover to cover and you'd know it exists. And then you'd think, okay, so now I've got my bubble sort, I'll make it so I can call it on any array. And yeah, it wouldn't take that long. It wouldn't take that long to get to that level. But if you started trying to write a linked structure and then bubble sort through the linked structure, yeah, insertion sorts still don't have to have linkage because you can work through arrays. And of course, the right answer is to say array.sort because it's already there.
So I already have the microphone. So as a C++ programmer, the syntax of Rust, it's really, as a first look, to me, it results awful. It's really intimidating. And I know there are efforts like Zig or Carbon that tries to give the same advantages of Rust in terms of security and safety with a syntax which is more familiar to system programmers. In your experience, is there any reason why things that look so alien have been designed this way? Have you evaluated the other languages like Zig or Carbon, or which are far less popular than Rust? And I'm not sure why.
I can certainly explain why the syntax looks as it does.
Please.
And that's because the strongest influence over the development of Rust was not the C and C++ family of languages. It was the ML family of languages. So the original Rust compiler was written OCaml. And things like, have I got an example of it? I don't think I have, actually. Oh, yeah, I have, yeah. So this approach here to creating name and type. As a C programmer, it's burnt into you. The type comes first and the name comes second. And it takes months to not type in the wrong order, get the checkers you type. This is the other thing about Rust Analyzer. When you get it in the wrong order, that's fine, because Rust Analyzer will tell you it's in the wrong order, and it's totally trivial to fix. And because you're being slowly trained by the tools as you work through, it's not as painful as it sounds. But yes, simply putting the type second is really hard for C programmers. It's totally natural to people from other programming cultures.
Both languages he mentioned put the type after the name, too. It's generally received that C did it wrong, but...
Okay, so that's not perhaps the best example. Yeah, I'm not going to go deeply into Zig. David might if he wants to, because I don't know it very well. I believe that Zig does not solve memory safety as completely as Rust. The fact that Rust guarantees are so strong is one of its most attractive features. Carbon is also seeking to chase similar ideas. I think, again, it's going to take a slightly weaker stance on memory safety. Carbon is a fantastic idea for modernizing and interoperating with C++. The people who are making it are not advocating it as the best place to start a Blue Skies project. So if there's something else you want to add about Zig, David, do feel free.
I mean, it takes a very different attitude toward what problem are we trying to solve here. Rust, the fundamental thing of Rust is memory safety, and without the keyword unsafe, you cannot have an invalid pointer in your code. Zig takes an approach of let's help the programmer not have invalid pointers, but the compiler is not able to determine a lot of that for you.
I mean, the other
Also
language that you perhaps could have mentioned would be Go. Go is also memory safe through the use of garbage collection. And that has pros and cons as well. But it plays in a similar place to Rust. It's a systems language, but not a systems language that you choose to go down and write an operating system in.
They've also placed a strong emphasis on simplicity in Go.
They have, yeah. So yeah, to some extent, it's a try it and see how much you like the differences. I've come to find them kind of charming in their way. And I suppose I'm quite pleased it's still curly brace language. But yeah, I wanted to put this up so that you could see some Rust. I'm aware that it does kind of make your eyes hurt if you've not read it before. Cool. Well, in that case, thank you very much for your attention. I hope you enjoy your coffee.